program to input a number and display whether it is a Armstrong number or not. Now, this program also we will be doing using sub procedure as well as function procedure. So first we will do with sub procedure. Okay. So for this, let's declare our sub procedure, declare sub. Now this is an Armstrong program. So let's change the name of our sub procedure, Armstrong. So we need one number as an input. So for that we have parameter n. Now CLS, then what we do is we take one number as an input. Now what we have to do is we have to call the sub procedure. So calling is done through call keyword. Now let's write down the name of the sub procedure, which is Armstrong. So okay, this is the end of our main module. Now let's go towards the definition part. So let's change this into sub. This is going to be Armstrong. And all these things we will remove. Okay, here we are with our definition part. Okay. Now, before solving this particular program, what we should know is what number is Armstrong number. So this is what we should know. So, okay. So those numbers are said to be Armstrong numbers whose individual digits when we cube and when we add them together gives the original number. Such numbers are said to be Armstrong number. Maybe whatever I said might not be clear right now. So let's see through one example. Okay. The first example is, let's say, a number 153. Now, in order to check whether 153 is a Armstrong number or not, what we have to do is we have to cube all the digits. That is, we do one cube. So this is the symbol to cube. Exponentiation 3, that is, this is one cube. Then what we do is we cube all the digits. So let's start cubing. That is 5 cube. Then we have one more digit, which is 3 cube. Okay. So we have cubed all the digits. After we have cubed all the digits, then what we have to do is we have to add all these numbers. So what we have to do is we have to add all these numbers. And after adding all these numbers, if we get the original number, that is, if we get the original number, which is 153, then this 153 is an Armstrong number. So basically what we have done is we cube all the digits, we cube all these individual digits, and after cubing we add everything. That is, 1 cube we add with 5 cube, the sum we add with 3 cube, and after addition, if we get our result as the original number, then we say that this number or such numbers as Armstrong numbers. So this is actually an Armstrong number. So let's see. 1 cube is 1. Now 5 cube is 125, and 3 cube is 3 is 9 27. So let's add all this together. So when we add, we will get 153. So 7 plus 1 is 8, 9, 10, 11, 12, 13. When we add with 5, 13, 3, carry over 1. So 2 plus 2, 4 plus 1, 5. And 1 is only left, so 1. So it is 153. So there are other Armstrong numbers as well. Now, if you want to know about Armstrong numbers in detail, then yeah, there is Google. You can Google it over there, okay, to find other numbers. So in our example, while we check our program, we will be using this particular number to test whether our program is correct or not. Okay. So the first thing that we have to do is we have to extract. This is the first thing. Okay, talking about loop, our loop will be the same as that of before because we have to extract characters one by one. So until and unless the value of n becomes 0. But actually, if user types 153, then it will be stored in this variable n. And when we extract and we start extracting digits one by one, and until and unless the value of n becomes 0, we have to repeat this process. So what we'll do is extract each digit. So extract is each digit. And after extraction, what we do is we have to cube the digit. This time we have to cube the digit, and we have to cube the digit. We have to sum and store in a separate variable. Okay, this is all we have to do. So extraction of digit, it's the same as that of before. Now cube the digit means whatever digit we extract, that digit we have to cube. Then we have to add and store in a separate variable. We'll see in a while how we can do this. Then after this, it is the same, that we have to remove the last extracted digit. So what we do is we remove the extracted digit. So this is what we do. So remove the extracted. So what we do, we remove the extracted digit. So these are the 3 steps that we have to follow. So let's see this in an editor. Okay, the first thing is let's form a loop while n is not equals to 0. Now what we have to do is we have to extract. So in order to extract, we'll be using R. So R is equals to n mod 10. So this is how we extract. Now after extraction, what we have to do, we cube the digit, sum them, and store in a separate variable. So let's do this. So this means we have to use a separate variable. So for this, I'm using arm as my variable name, that is arm is equals to, since we are trying to store this sum in arm, so arm will repeat, which is arm is equals to arm plus, what we have to do is we have to uh, store the cubed digit. So our digit is stored in R. So R is not enough. If we just write like this, then it is going to be sum of the digits. Okay. So instead of, in order to prevent from being sum of the digits, what we have to do is we have to cube this variable R, which stores the extracted digits. So we have to cube this R cube. So what is happening now at the beginning over here? 3 will be first of all extracted. 3 will be extracted. 3 will be stored in this variable R. Now what is going to happen? 3 cube. 3 cube means 27. 27 is going to be stored. Next time 5 will come. So 5 will be stored in R. So 5 cube, that is 125. 125 will be added and stored in variable arm. So this is how it works. So we'll see all these things while we trace our program as well. Okay. So our last step is to remove the extracted digit. So it is the same statement that we've been using, that is n is equals to n/10. Now when, okay, now what we have to do is, after we have followed all these steps, then what happens is we have variable arm over here. So arm will hold one value. Okay, in this particular case, it will hold value 153. So what we have to do, we have to check the value of arm with our original number. And if the two values, that is n's value, that is our original number's value, and our arm value are equal, then we know that it is a Armstrong number, else it is not a Armstrong number. So this is what we have to do. So in order to check now, if we have to check with the original number, but our original number over here, it has been continuously been divided. And at the end, the value of n becomes 0. So what we have to do is, in palindrome program also, it was the same thing. We have to check with the original number. So for that reason, what we do is we use a extra variable, that is onum, and we store our original value in this onum variable, so that whatever happens with n, it doesn't get, our original number doesn't get affected. So our original number holds, onum holds our original number. Now this n, we do not bother about this, because This has been continuously divided, it becomes 0. It whatever it becomes, it's not that much important because our original number is safely stored in onum variable. So let's check with onum, that is if onum is equals to n, then so if this condition is true, then we know that our input number is a Armstrong number. So what we do is we display the number is an Armstrong number. Else, if this condition is false, then we know that the number is not an Armstrong number. Is not an Armstrong number. Okay. So this is our Armstrong number program. So first, let's run our program and let's check our output. So suppose if user gives 1, 2, 3, 4. Now this is not a Armstrong number. The number is not an Armstrong number. Now suppose if we give one Armstrong number, which is 153, then it is to display the number is not an Armstrong number. So there is something mistake in our program. So let's find out that particular mistake. The mistake is that we have to check our original number, not with n. What we have to do, we have to check with this variable, that is arm, because arm is the variable that we have used to store the actual sum of all the cubed digits. So instead of n, what we have to do is we have to write arm. Okay, now let's run our program. Let's give 1, 2, 3, 4. It is not an Armstrong number. Now let's give Armstrong number, which is 153, and it will display the number is an Armstrong number. Okay, now we have already seen the output. Now the only thing remaining is to trace the program. So let's trace it. So at the beginning, what will happen is user will give one number. So we are assuming it to be 153. Then that 153 number will be safely stored in variable onum. So now we have another variable onum, which will hold the same value or our original number 153. Now we are into this loop. So n more, so n is not equals to 0. 153 is not equal to 0 is true. So it will come to the body part, it will find r, and r will get a new value, that is n. This when divided by 10 will give us the last digit, that is 3. Then we have this particular statement arm. So arm is equals to arm plus r cube. Arm plus r cube means arm at the beginning, it doesn't hold anything. So qbasic treats it as 0. So 0 plus r cube means 3 cube. So 3 cube is 27. So 0 plus 27 is 27. Now we come to this line, n equal to n slash 10. Okay, as that of before in our previous programs, we have already discussed that whenever a number is divided by 10, and if we do integer division, then the last digit will be removed. So 3 will be removed. When will take us to the condition, that is 15 is not equals to 0. This condition is also true. Then we come to this line, r equals to n mod 10. N mod 10 means it will extract the last digit. 5 will be extracted. It will be stored in r. So we have 5 over here. Arm equals to arm plus r cube. So value of arm right now is 27. 27 plus r cube is 5 cube. 5 cube is 125. So 125 plus 27 is how much? So 125. Okay, let me see. 125 plus 27. It is 125 plus 27. And this is 152. So we have 152. And that 152 will be stored in arm. 152. Okay. Now then we come to this line, n equal to n slash 10. Again, the last digit will be removed. That is 5 will be removed. When will again take us to the condition. Condition checking will take place. 1 is not equals to 0 is true. 1 is not equals to 0 is true. So we come to this line, r equals to n mod 10. Since there is only one digit, same digit will be extracted and will be stored in r. So r holds 1. arm equals to arm plus r cube. So value of arm is 152. So 152 plus 1 cube means 1. So 152 plus 1 is 153. So we have 153. Then it is n equal to n slash 10. So 1 will be removed and we remaining will be 0 over here. When will again take us to the condition, which is 0. 0 not equals to 0 is false. Now, since our condition is false, our loop will terminate. It will come below when, and here condition checking will take place. So onum 153 is equals to 153. Now this is true and it will display the number is an Armstrong number. Now suppose the input was 1 2 3 4, then what would happen? 4 cube, 3 cube, 2 cube, 1 cube would be added, and that result will be stored in 153, sorry, in this arm variable. And when while checking that, sum will not be equal to this whole thing. So at that time it displays the number is not Armstrong number. So this is how we can solve Armstrong number using sub procedure. Okay, now what we'll do is we'll quickly convert this sub procedure program into function procedure. So let's move towards our main module. Now we'll solve the same program using function procedure. Function procedure, declare function Armstrong. Again, now we have to talk about the dollar sign because we are writing program using function procedure. So this particular program, as we have already seen the output clearly shows us that it is a string value because the output is the number is a Armstrong number, or we display the number is not an Armstrong number. In either of the cases, it is a string value, and that particular string value is what our function is going to return. So since our function returns a string value, we have to write dollar sign. Okay, now n, it is a parameter to store the past value. When the function is called, we have CLS, then we have this input statement to take one number as an input, then we have to call our function procedure with print keyword. Now talking about message, over here also message is not required because whatever our function returns is itself a message. So extra message is not required. So dollar sign it is required. So this is the end of our main module. Now let's go towards our definition part. And let's replace this first of all. So function, and we have Armstrong dollar. Now this onum, this is the same that first of all we have to store the original number in one separate variable, and for that we are using onum. We have a loop which is the same. Now this, in this whole loop, what will happen is all the digits will be cubed, and it will be summed up, and it will be stored in variable arm. So at the end of this loop, what will happen is when the loop gets terminated, what happens is all the digits will be cubed individually and its sum will be stored in variable arm. And after that, what we have done over here is condition checking. So we have checked our original number with the with the value that is stored in arm, and if these two numbers are equal, then we say that the number given by the user is an Armstrong number. If these two are not equal, then we say that the number is not an Armstrong number. So the only change over here is we have to return the value, and in order to return the value, we have to write down the name of the function procedure, which is arm Armstrong dollar is equals to, and same thing, arm Armstrong dollar. Okay, here is arm strong Armstrong dollar is equals to the required value. So this is how we return the value. Okay, now let's run our program. That is 1 2 3 4. The number is not an Armstrong number. Suppose if we type 371, the number is an Armstrong number. So 371 is also a Armstrong number. Now let's check for our number 153. This is also a Armstrong number. And if any other number, that is 123, this is not a Armstrong number.
Thank you so much for watching. Please do like my video so that I get motivated to create more of these videos. We would appreciate if you would share this video with your friends. And if you have any queries and suggestions, let me know through the comment section. Lastly, please do subscribe my channel and press the bell icon so that you get notified every time I post a new video. Thank you.